Okay, I am going to start the lesson. We are solving radical equations today. And you want to write this down. This is not fill in the blank notes. I decided to do something a little bit different. So just go ahead and write this down on a piece of paper, following along as I go, and then just kind of stopping as you need to kind of really understand what I'm writing down. So we are solving radical equations. So we're going to have equal signs involved, and we're going to have radicals. So our goal is to isolate the radical, get it by itself. And then once we get it by itself, to undo the radical, we're going to square both sides and then solve the variable for the variable, okay? So if we look at example number 1, we're going to have something like this, okay? Now, when you look at this, you kind of think of it as just like, well, what if the radical wasn't there? How would I solve for x? So if the radical wasn't there, I would subtract 2 from 12 and then divide by 5. So I'm going to do the same thing. Subtract 2. I get 10. I'm going to divide by 5. I'm going to get square root of x equals 2. Okay? Well, in order to get rid of the square root, we're going to do its inverse, which means we're going to square both sides, because whatever we do the first side or one side, we have to do the other. So now we're going to get x equals positive 4. Okay? We will get to some more difficult ones later on that we are going to have to look for extraneous solutions. So we're going to go ahead and start doing that now. When we look for extraneous solutions, what we are doing is looking to see if we plugged in. So sometimes we'll get 2 answers, and if we plug them back in, sometimes they won't work. They won't come out to a true statement. So when we look at this, if we check it, we're going to get 5, and then instead of rad x, we're going to put 4, because that's what we said our answer was. Okay, so I'm going to go ahead and do this. This is going to be 5. This is times 2 plus 2 equals 12. Well, this is going to be 10 plus 2, and that does equal 12. So that is a true statement. Therefore, this 4 is an answer. Okay, so let's try one more before I have you try and work on some on your own. So here is the second one. Rad 3x minus 2 minus 7 equals 0. Okay, so in this case, we've got a lot going on underneath the radical, but the goal, remember, is to get the rad by itself. So if you think of it like we want to isolate that, if there's a minus 2 over here, then that means we have to add, minus 7, not 2. We're going to add 7 to this side. So we're going to get rad 3x minus 2 equals 7. And now, in order to get rid of the rad, we're going to square both sides. Whatever we do to one side, we have to do the other. Now we've got 3x minus 2 equals 7 is 14, 7 is 49. And there we go. All right, the last thing we're going to do now, actually not the last thing, second to last thing we're going to do is we're going to add the 2 to get 51. The last thing we're going to do is divide by 3. So 51 divided by 3 is 17. So x equals 17. All right, so we're going to go ahead and check for extraneous solutions. So if the problem just says to solve, then that means that there's not any extraneous solutions. But if it says solve and check for extraneous solutions, then you have to go back and plug back in, okay? So let's go ahead and do that here. We're going to do 3 times 17 minus 2 minus 7 equals 0, okay? Well, 3 times 17, that's going to bring us back to that 51. And 51 minus 2 is going to bring us back to that 49. Hopefully you can start to see that we are definitely going to get a 0. 7 minus 7, and that does give us a 0. Okay, so we are good. All right, I'm going to stop and let you guys go ahead and do a couple of the practice problems that I put down for you.